A very good morning to everyone, to my panel, Dr. Rohana, and my second panel, Puan Aiman Hanis. My name is Tai Weng Hung. Today I would like to present my PSM title, Conceptual Design Selection Analysis for ELV General Dismantling Tool. Now I will brief about my Chapter 1 Introduction. Background of study. Vehicles are one of essential items that in the usage and disposal process inflict major environmental harm. However, significant environmental and economic benefit can be expected when a suitable recovery strategy is applied. Dismantling of ERV is the process of disassemble the part of or body of vehicle that are end of its life existence. It is very important to measure the better assembly and disassembly process not only for safety but also ease of dismantling process. Hence, in this project, research develop a new design ELV tool has become our target to analysis. There are a few problems when assembly or disassembly a car or vehicle. Firstly, the time that required to assembly or disassemble vehicle is longer due to we need to change different kind of tool in dismantling process. Besides, current car tools have many types and this requires more space to keep because they have many different type of tool. That's very important design for dismantling because it makes this construction process and the procedure to planning and design easy. The main objective of this project title is to analyze the current tool and techniques and compare with the new design ELV tool for ELV dismantling process. Secondly is to propose a new design concept for a new design of ELV tool. Lastly is to make a prototype for a new design concept of ELV tool. For the scope, in this project research, different type of tool will be used to become a combined design. Current vehicle nowadays is require many tools and techniques in assembly and disassembly process. There is many different type of tools are required also when ongoing assembly and disassembly process, and this will make high lead time also. Hence, current design tool can be combined to be a one new design. The disassemble or assembly time can be shortened. There is a few of significance of this project. Firstly is to study and better understanding on different types of tool depending on the function and purpose. Second is generate the idea and concept of design for your new ELV tool by using concept design tool. Thirdly is to study and better understanding of the desirable design of the dismantling tool. Lastly is to be widely analyzed in order to make this research a reference or benchmark for future study. Now I would like to present my Chapter 2 Literature Review. The end of vehicle is a vehicle that can no longer be used. It could be a car or van at the end of its life. These vehicles are no longer usable and contain toxic elements such as liquid and components classified as dangerous waste by French Decree 2002. Such components must be handled separately and the rest of vehicle, mostly for raw material, can be recycled. Yichong Wong, Karam and A.L. Obadi, Nohayati Mayuddin at 2018 said the ELV could be split into X vehicle and natural electric vehicles. Retread cars are referred to as early ELV and unserviceable cars owing to collision, fire, and physical defect triggered by vendors. A proper ELV program will lead to sustainable management of the environment through the 3R principle, that is reduction, reuse, and recycling. The definition Nations are made involved into 6R: minimize, reuse, recycle, restore, remanufacture, and rebuild, which demonstrate how comprehensive and effective ELV program can be accomplished by M.Z. Massaman and Jaquan G. Brown at 2012. ELV may also aid automotive repair by reusing potentially cheaper body than new ones by Z. Mohammad Jawi, F. Lamin, A. R. Abdulmanap, K. A. Abu Qasim, F. Abbas, F. G. Wong at 2012. ELV recycling system. The ELV recycling process is known as the process of decommissioning, depollution, and shredding. During the dismantling cycle, the recycle performance of the part is greatly increased and the element is rendered reusable. Decommissioning business may be classified into two categories of industry. The first includes extremely valued part industry gathering and process useful resale product. The second consists of scrapyard company which hold the ERV in order to collect the parts slowly and then be offered to nearby repair facility and to do it yourself DIY operators by Artura at 1997 years. For ERV2, there are plenty of automotive hand tools available and they are certainly relevant by JCBL hand tools in 2017. For example, user would use the wrench to open a nut. There are flexible clamps in varying types, including 1 per half inch, 3 per 8 inch, 3 per 4 inch, and 1 per 2 inch. Adjustable wrinkles should be tailored to different sizes and the same clamp can then be used for varying use by JCBL hand tools at 2017. I would like to present my chapter 3, Methodology. This is my flowchart of the project. A flowchart is a visual aid in project management to grasp the method used by project management. The timetable demonstrates each action in the procedure is stated clearly in the flowchart. This flow is divided into 5 main stages to ensure and promote the accomplishment of the mission goals area. This is my Gantt chart of the project. Gantt chart is widely used in project management. It's one of the most prominent and effective ways to display time control activities. For the project selection for the design, these four types of tool has been chosen: the spanner, screwdriver, the knife, and the top wrench. Now below are the current tools for car dismantling process. There's a sturdy wire or C-clamp, a set of screwdriver, a set of Richard wrench, a rubber mallet or a medium-sized hammer, pliers, and an engine pulley airframe. For a preliminary result for this project, new EAV tools are able to reduce the assembly or disassembly time of vehicle components and saving space to keep the tool. Lastly, the new EAV tool will be able to make industrial vehicle activities going process more easy and can solve problems in emergencies such as car accident. Now I'm going to present my chapter 4 result and discussion. In this project, 10 conceptual design has been developed from the initial design together with an analysis based on Lucas DFA methods. For each of the design, a function analysis, feeding analysis, and fitting analysis has been done in order to calculate each design functional efficiency, fitting ratio, and fitting ratio. This is my final design for the concept 9. The design is almost same with the spanner, but I just add on a screwdriver, knife, at the top bench. This because this design will be more familiar or easy to use by the user. Other than that, because the design of the screwdriver, it will be useful in emergency case such as car accident. For example, when you undergo the car accident or fire accident, you can use this tool to break the door easily because the design of the screwdriver. This is my Lucas DFA analysis for the concept 9. For the functional analysis is 100% because all the tool is included. For the fitting ratio is 1 and the fitting ratio is 2.85. I chose this design because the fitting ratio and feeding ratio is the most optimum, most low compared with the other design too. HOQ method tests house of quality metrics also uses in order to choose the most optimum design among the 10 concepts. After choosing the final design, the design is drawn in the SolidWorks and this is my design drawing. After the undergoes the detail drawing in SolidWorks, the machine SLS that is selective laser sintering is used to make a 3D printing for a final prototyping. This is my prototype budget planning. The total part that need to print, the total amount is about 240 ringgit. Now I would like to present my chapter 5 conclusion. There is many significant results of this project. In the student research, the study in HOQ in quality function deployment methods and Lucas DFA method. Each of the developed conceptual design then were analyzed with 3 different analyses based on Lucas DFA methods. After undergoes the suitable analysis, SolidWorks software is used to draw the chosen detailed design. Lastly, technology of selective laser sintering is used to make prototype of the product. However, there is a limitation of this project. For example, this task was carried out for just 1 year because of the time limit and the supplemental plan and the other subjects were allocated. Lastly, the model design of ELV2 had some defect parts and hence not able to give complete detailed design models. After undergoes this project, for the future study, we hope we will perform another DFA approach such as bootstrap or Hitachi DFA method to determine which design have the highest level of easiness during assembly process. Second is to perform questionnaire survey to the industry expertise to study the level of preference for each of the selection criteria. Lastly is to use CNC machining to make prototype to ensure the stability of dimension and have high resistance to mechanical wear and corrosion. All for me. Thank you.